Okay, this is an application question where you are given that for a data from a normally distributed population, this is good to know from the beginning that it's normally distributed. You will see this in a second. We have the following information, and then they give you a bunch of numbers. They give you the X bar, which is the sample mean, N, which is the sample size, sigma, which is the population standard deviation, and alpha, which is the level of significance of the test. And then the question is to use the critical value approach. But I just want to make sure that you understand this critical value approach. We also call it the traditional approach. Traditional approach, or the Z value approach. It's another name for it. To perform the test, and then you are given the null and alternative hypotheses. One thing is that you can get lost with all the information that's given to you at the beginning. But I'm going to tell you what to do when you have such questions. What you do, what I would do at least, is first I want to understand what kind of test do I have. Is it left-tailed, right-tailed, or two-tailed? If you watched part 1, you understand that you immediately look at the alternative hypothesis, and because it has a bigger than, immediately you know that the test is right-tailed. So you write it immediately. This is a right-tailed test. Plus the fact that the level of significance is given. These two together, if you watch part 2, you'll understand that these two, knowing the test type and the level of significance alpha, you can find the critical value. So because it's a right-tailed test, now we will go to the next page. This is the picture that we have, and we know that the critical value is going to be here, and we want to find it. So I'll leave a box here for us to find. And what we are given is that the alpha, which is the area of the rejection region, is 0.01. So if you remember, I will tell you, how do you find the critical value? You know that the probability that Z is less than this critical value, this is the area to the left of the critical value. But you are given the area to the right, so you'll do 1 minus alpha. And if you do 1 minus 0.01, you'll get 0.99. And you can add 2 zeros here because you know that you'll be using the Z table, and the Z table is given to you with 4 digits after the decimal. So I will skip using the Z table because by now you should know how to do it. And if you use the Z table, you'll get that the critical value is equal to, but please check it, it's 2.33, 2.33. I leave this to you because there are many videos where I show you how to use the Z table. So we go back and we write that the critical value we found is 2.33. Okay, that's good. So now we have the critical value. So once you are done with finding the critical value, just remember what it does. What the critical value does is that it separates the rejection region from the non-rejection region. So in this case, this will be our rejection region, and this will be the non-rejection region. So what do we do next? Next, you need to compute the test statistic. And that you get from looking back at the question. You are given the sample mean, the sample size, and look, you are given the population standard deviation sigma. So you can say that I have sigma, in this case, is known. In some cases, you might be given S, which is the sample standard deviation, in which case the thinking will be different than this. But now, the fact that sigma is known and that we have a normal distribution from the beginning, go to this table. If you remember, this table summarizes what you have to do. If sigma is known and the population is normally distributed, then to compute the test statistic, this is the formula that we will use. This is again for the test statistic, which is in this case this formula. So let us use this formula to compute the test statistic. So we go back, let me compute it here. So Z equals X bar minus mu over sigma divided by radical n. Before I write it, let's make sure that we have all of them. X bar, mu, sigma, and n. So X bar is here, yes. Sigma is here, n is here. But where is mu? Okay, for such questions, you always take mu to be the number that you see here. Of course, or here. It's the same number. So take the number here as your mu for the test statistic. So it's 40.5. And so let us do it now. So X bar was 44.3 minus mu is 40.5 divided by sigma is 9.5 divided by radical n, n is 35. If you do this on your calculator, you will get exactly 2.3663. But of course, you will not take all of these digits. For z, if you remember, for the z value, we always approximate to 2 digits after the decimal. So this is going to be, let me write it with a different color. It will be 2.3, and we have 6, so this will be 7. So it's 2.37. Now, what we have to do is to find where is this in the normal distribution. 2.37. So you know that the critical value is 2.33. Now the test statistic, let me just write on top of it that this is the test statistic. This is the Z. And it's 2.37. You know that 2.37 is bigger than 2.33, so it will be here. Let me use a different color for now. Let's say this here is Z equal 2.37. This is the one that we found here. So what do we notice? We notice that this Z lies in the rejection region. So it's here. It's inside the rejection region. So this means that we reject the null hypothesis. So I will go back and write what we found here. So you can say here in the solution, so let's say solution, the critical value that we found. So, okay, I will say this. You say that this, you don't have to write all of it, so, but just to remind you, this is a right-tailed test with level of significance alpha equal 0.01. So this is the first thing that you have to notice when you read the question. Okay, the alpha and the type of test. The second thing is, therefore, we saw how to compute the critical value, and our critical value was 2.33. Then we moved on and computed the test statistic. In this case, the test statistic turned out to be Z equals 2.37 approximately. And the critical value was 2.33. And because of the picture that you see here, that the test statistic turned out to be, and it's a right-tailed test, of course, turned out to be more than the critical value, so it lies now in the rejection region. If it was a left-tailed test, then your critical value will be here, and if you get a Z bigger than it, then it's in the non-rejection region. Okay, for a left-tailed test. Make sure that you don't take this for granted, that if the Z is bigger than the critical value, then you reject the null hypothesis. It is true for this case because it's a right-tailed test. But if it was a left-tailed test and your rejection region is here, then any Z that lies here will make you reject the null hypothesis. Okay? So I will erase this, this part, but I hope that you understood what I just said. And we go back and we write here, therefore, we reject the null hypothesis H0. This is our decision from here. And this is one type of question. You know, if try by yourself to solve the same question, but put a less than here and a bigger than or equal for H0. And please try solving it and see your answer. You verify it by just looking at my previous videos, and they will tell you when to reject if you have a left tail test, because if you put less than for the alternative hypothesis, it will be a left tail test. And then look at when do you reject when you compute the Z. Another thing that is important is remember this table. So always look at the given in the question. In our question, sigma was known, and it was a normal distribution. But it could be another case. So always pay attention to these two things at the same time. The type of test and how to find the test statistic. The type of test and the level of significance will allow you to find the critical value, and the given in the question would allow you to find the test statistic. And then you compare them. And we saw that we compared, and we got that we need to reject the null hypothesis in this case. And so I will stop here.